Lesson 10.2, page 552, Graphing Cube Root Functions. In this lesson, you will learn how to graph a cube root function, how to compare a cube root function using average rates of change, and how to solve real-life problems involving cube root functions. A cube root function is a radical function with an index of 3. So an index of 3 means we have a cube root, so radical with 3, cube root. You can see I'm pointing at it right there. The parent function for the family of cube root functions is the cube root of x. So that's the parent function. I have it circled. It's the most basic cube root function you can have. The domain and range of the parent function are all real. So I can plug in any value for x and it will give me any value for y. Let's talk about graphing a cube root function and what it looks like. I have it drawn here. Remember your perfect cubes? We've had these in the last chapter. I'm circling them here. You know, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. These are your perfect cubes. So you want to plug perfect cubes in for x. So if I plug in 0, the cube root is 0, 0, because 0 times 0 times 0 is 0. If you plug in 1, the cube root of 1 is 1. If you plug in 8, the cube root of 8 is 2. 2 times 2 times 2 is 8. And if you use the opposite values, it will give you the opposite response. So if I graph those, can you see how if I go 8 left and 2 down, there's a point, and 1 left, 1 down, and 0, 0, and 1 right, 1 up, and 8 right, 2 up, and I get this wavy thing. There's a cube root function. Now, the graph of the parent function increases on the entire domain. In other words, as I go from left to right, you can see this thing continually gets higher up on the graph. You can transform graphs of cube root functions in the same way you transform graphs of square root functions. So we reviewed this in the last lesson. Remember, inside horizontal, those are backwards from what they seem. Outside vertical, those are the normal transformations. Let's graph a cube root function and then compare it to the graph of the parent function. So when you look at this, do you see how we have -4 outside the cube root? That means we are going to translate our graph 4 units down. You can use your calculator to help you with this. I'm going to use the website that I showed you in the last video to type these both in so you can see them both. So I did that here. Here's the parent function, and I'm just going to draw on this. So you can see the parent function, it crosses through 0, 0. Here's 1, 1, and we said 8, 2, and -1, -1, and -8, -2. And -4 means I'm going to take this and move it down 4. So if you look at each point, this point is down 4. That point, 1, 2, 3, is down 4. This point down 1, 2, 3, 4. You notice this graph has just really been pushed down 4 units. Ultimately, the book would like you to try or be able to take the parent function and do the transformations without your calculator. I think I'm going to let you use your calculator on quizzes and tests for this, but if you could do it without, if you're looking at straight A, you probably should be able to transform these without your calculator. So in this problem, they're saying, here's g of x, describe the transformation from the parent function. So that should be pretty easy to do. Let me take a highlighter out. First of all, the graph is stretched by a factor of 2. Secondly, do you notice it's going to be translated 3 units right, because -3 inside actually means 3 right. And the third thing, it's going to be translated 4 units up. So you can see each of those things. Let me color code. Can you see? Stretched by a factor of 2, translated 3 right, and moved 4 up. Let's actually graph that then. Okay, I'm going to actually graph this. Here's the parent function. and this is what they want me to graph. So I can actually get this done even without my calculator. So if I just take the parent function, watch this carefully. Now this point is at 0, 0. Multiplying 0 by 2 doesn't do anything, so that's going to stay. But this point, you see how it's 1 unit up? This is saying double, okay? Stretch by 2, double. So instead of 1 unit up, I'll move it up to here. And this point, instead of 2 units up, I'd move it to 4. And this point, if I double 1 down, it would become 2 down. And if I double this point, which is 2 down, it will become 4 down, okay? Now let me take my highlighter out, so I got a couple more things to do. This says right 3, up 4. So let's take each of these points, and let's go right 1, 2, 3, and up 1, 2, 3, 4. And I'll take this point, 1, 2, 3, 1, 2, 3, 4. And I'll take this point, up over 3, up 4. Then take that point, which I had, out over 1, 2, 3, and up 4. And then this point, over 3, and up 1, 2, 3, 4. And now I just translated this thing, and this graph would now basically do that, okay? Kind of hard to draw because you're trying to connect the dots as best you can. I'm trying to, but that would be what the new graph would look like if I stretch it by a factor of 2 and I slide it 3 right and 4 up. And you can kind of see in the book, you'll see a picture of it, and you can see that picture here. That's just what I drew. That's exactly what I drew here in this picture. So really, you could take the parent function and apply these transformations without even using your calculator, but if you're not there, if you needed to type it in your calculator, make a table and do it, I'd be okay with that right now too. What I'd like you to do is pause the video. I want you to do 4, 5, and 7. We're going to compare each of these to the parent function. I don't need you to graph them. You can use your calculator for that later in the homework. But compare 4, 5, and 7 to the parent function. Pause the video and do that. And there are your comparisons for 4, 5, and 7. Double check to make sure you're getting these. If you aren't, make sure you ask in class tomorrow so we can talk about that. In the last video, we reviewed average rates of change, and we're going to be using that again in this lesson. The graph of the cube root function is shown, so here's the cube root function. And then we're going to compare the average rate of change of the cube root function to this function for the interval of 0 to 8. So let's do that. First of all, for the function m, if we're going to go from 0 to 8, here's 0, 0. But when I go over to 8, that's the 0.88. So let's quickly get the rate of change for this. Remember, y's on top. Here was the slope formula. I hope you remember it. It was that. So really, we're just using the slope formula here. We're doing 8 minus 0 on top. Those are my y's. And 8 minus 0 on the bottom, those are my x's. I get 1. So the average rate of change for function m, it's right there, it's 1. Now let's go to this function, h of x. So I'm going to have to plug in 0 for x and 8 for x and figure out what I get. So let's plug in 0 for x. 1/4 times 0 is nothing, and the cube root of nothing is nothing. And then I'm going to plug an 8 in here. I'm going to work that out a little bit. I got 1/4 times 8. 1/4 of 8 is 2. And if I take the cube root of 2, let me check on my calculator what that gives me. I'm getting cube root 2. I'm getting 1.26. So if I plug in 8, I'm getting 1.26. Okay, let's get our slope. 1.26 minus 0, those are my y's, and 8 minus 0 for my x's. 1.26 divided by 8, I'm just doing it in my calculator, I'm getting about 0.16. So the rate of change for graph M is 1, and the rate of change for h of x is 0.16. Obviously, m is much greater. Let's see how many times greater. I'll take 1 and divide it by 0.16, and when I do that, it looks like I'm getting 6.25 times greater. Okay? So a much greater rate of change for graph M than h of x. So let's see, they have 6.3, I have 6.25. To wrap up the video, we will solve some real-life problems that have cube root functions. The shoulder height in centimeters of a male Asian elephant can be modeled by this function where t is the age. So this function compares the age of the elephant to how tall it is, basically. Estimate the age of an elephant whose shoulder height is 200. So here they're saying the height of the elephant is 62.5 cube root t plus 75.8. Here they're saying the height is 200. Well, this should be pretty easy to solve using the intersect feature of our calculator, which you've done. So let's take our calculator out, and we're going to type in the function for the elephant. So that was 62.5. Now you haven't used the cube. There's no cube root button on the screen. We have a square root. Here's how you get to cube root. Math key, hit the math key. Option 4 will give you a cube root, and I need cube root of, well, they don't have a t, we have x here. I have to close parentheses, add 75.8, and then my second equation is just y equals 200, because the elephant is 200 centimeters tall. Now, if I hit graph, remember to use the intersect feature, you're supposed to see where both lines meet. This is zoomed in pretty good, and I don't see two different lines or curves, so I'm going to zoom out. I might have to zoom out more than once, so I hit zoom 3, enter. Now it's zooming out. Waiting for a minute. I still don't see that other line. I'll zoom out one more time, and if I don't see it again, I might even try it one more time. Yeah, I'm going to try one more, see if I can zoom this out where I can see where these two things meet. Well, there's my, oh, there we go. Now I can see where these two things meet, and now I can use my intersect feature, second, calc, intersect. Remember, we're going to hit enter 3 times, 1, 2, and 3. And according to this, you can see it here, when the elephant is 200 centimeters tall, I'm pointing right now, it must be about 7.8 years old. So it's probably about, I just went off that. It's about 8 years. Let me hit it one more time. It was about 8 years you saw in there. Let me do that again so you can see it. Yep, 7.8. That's about 8 years old. Okay? So if I go back to the book now, you'll see that. That's what the book has. When the elephant's 200 centimeters tall, it's about 8 years old. I'm going to pause the video here. If you have any questions, make sure you ask in class.